So LeetCode maximum frequency stack. For this problem, you need to implement a data structure that allows you to push a number and to pop the most frequent element in your data structure. And if there is a tie, so you have two elements that have the same frequency, then you want to remove the element closest to the top of the stack, meaning the element that has been pushed the latest. Okay, so let's see an example here. We are pushing all of these numbers and then we are popping 4 times. So after pushing, the stack is like this. You pop once, so you remove 5 because you have 3 5s and only 2 7s. And so now this is the updated stack. And now you pop again, and 7 and 5 have the same frequency, but 7 has been pushed in the latest. And so you want to pop that one. Perfect. So let's implement this. So we're going to have a class with 3 attributes. The first attribute is just a very simple map that maps every integer to its frequency, right? Then we're going to have another more complex map. This map maps every number to the list of integers that appear at least that number of times in our data structure. So for example, if you look into this map, you look up the value 5, then you get a list that represents all of the numbers that are in our data structure with a frequency of at least 5. Okay? And then the last attribute that we're going to have is just simply the maximum frequency, the global max frequency. And obviously it starts at 0. Okay, so now we're going to implement the push function. And the push function is just going to, first of all, update the frequency of the element that is being pushed. So that is just a simple algorithm. You just set as a default value 0, and then you increment whatever is there. So you just have a default of 0, and then you increment whatever is there, like this. And in this line, we also update the maximum frequency. So you update the maximum frequency with the maximum between itself and the incremented frequency of the element that is being pushed. Okay, so these 2 lines take care of updating the frequencies. Now we need to take care of the map. So now we have one more element that has at least frequency of x frequency. So we need to push that in the map of frequency of x, right? So you want to access the map using as an index frequency of x, and then you want to push that, to that x. So we're going to do that. So we just have the default, just like here. So here we were setting as a default 0. Now we're setting as a default empty array. So we're accessing the map with the frequency of x, setting the default. And now you want to push in this array, whatever is here, you want to push x. Because now you have one more element, which is x, that has a frequency of x, right? Perfect. And now comes the time of the pop function. So the pop function is going to have to pop from the map accessed at the maximum frequency, the global maximum frequency. So we want to look up the list of elements that appear at least max frequency times. And then we want to pop from that. And then if popping from that list causes that list to become empty, then that means that our max frequency has been reduced by 1, right? Because there are no longer any elements that appear max frequency times. So we're going to have to decrement that by 1. So let's implement this. So the first thing is you take the element that you're going to have to return from this.m accessed at this.max frequency. And you pop one element from it. And this also takes care of the tie. So if there are 2 elements that have the same frequency and it's the maximum frequency, you want to take the one that has been pushed the latest. So you want to use pop here. If you didn't use pop, but maybe you use the shift, you will be getting the latest one, the one that has been pushed the earliest. Okay, so now we have the element that we are going to want to return later on. Now we want to update the maximum frequency. So what we can do is we can access if the accessing this list at the frequency of x gives us an empty list. If so, then it means that popping from that list has just caused it to become empty. And if that list has become empty, it means that there are no longer any more elements with the maximum frequency. And so that means that our maximum frequency needs to be decremented. So first thing we do is we access frequency of x, which is obviously the same as max frequency, and we decrement that. So this is just taking care of updating the frequency of x because it has just been popped. So we want to update his frequency. And now we access the map at its previous frequency. So you see we access the frequency before the decrement takes place. And then we say, okay, is the length of the list at this position, at this index, 0? If so, there are no longer any elements with that frequency, and so we must decrement the maximum frequency. Okay, and now all that's left is just to return the x variable. So that's it. Once you know the solution, it's pretty simple. I submit a solution to show that it works. And the time complexity is O of 1, because you're not doing anything more than pushing, popping, setting a default here and there, incrementing something, decrementing something. There's no sorting, there's no priority queue, no heap, nothing like that. And the space complexity is actually O of n, because for any push, for every time push gets called, you just push one element in a map. So yeah, that's it from me today. Thank you for watching, and bye.